Okay, so here is the element builder. In the Power School, I already am posting a PDF of the lab sheet that goes along with the activity. So you can go ahead and open it, and it will be a PDF. And if you download Kami, which is a Chrome application or something, then you can actually write on a PDF. So hopefully you figured this out by now, but you just click on text and then you can write on this paper, and then when you're done, you save it and you can turn it in as a PDF. If you look on the lab, they also will give you, they'll also give you a Google Doc version, which you can type on as well. So this is what that looks like, and you can type on it here. But then what you just need to do is you need to download it as a PDF and turn it in that way. Okay, so let's just take a look at this particular lab. It's got some prior knowledge questions, and it's using a lot of this vocabulary. Okay, what substances make up water? Hopefully you know. That's H2O. If you're not sure what H2O stands for, H and O stand for, I also put a link for a periodic table. So you can come over here. Oops. That periodic table is right here. Okay. So H2O, hydrogen, O is oxygen. All right, so you're going to go ahead and put that in. What substances make up an iron pot? Well, if it's iron, it's going to be iron. Okay, so here it goes over what elements are. It talks a little bit about the atoms and where the protons, neutrons, and electrons are. And then it starts asking you to use your arrow button. So what I might do is like put this to the side. I don't know how big your screen is, but I don't like jumping back and forth. I like to be able to see the questions and see the activity. So here's my activity, and basically it's going to give you some instructions. Use the arrow buttons to add protons, neutrons, and electrons to the atom and press play. So you're just following these directions. I'm going to close this up. So I'm going to use the arrow buttons. Okay, so the protons seem to be going in this part of the atom. The neutrons are also going over there. And here's the electrons. Okay. They seem to be floating more around it. Okay, so what particles are in the nucleus? What particles orbit around the nucleus? You can answer those questions. Okay, and then it says show element name. What did I just make? I made lithium. Okay, and interestingly, I have 3 protons, 3 neutrons, and 3 electrons, in case I forget or it's hard to count. Okay, and what causes the element name to change? So you're going to go ahead and start. Let's see, if I change the protons, is that going to change the name? Oh, that changed it to beryllium, boron, carbon. Okay. What about if I change the neutrons? Nope. Electrons? Nope. Okay. So do you see how this is working? Okay, so you're just going to go and follow the directions. This section talks about mass number and atomic number and electrical charge. So I think it said at the beginning, but protons are positive. Okay. Protons are positive, electrons are negative, neutrons are neutral. Some people think neutrons are negative because of the N, but neutrons are actually neutral. They don't have a charge. So you're going to go ahead and change things and see how that affects the element notation. So right here, okay, what do you think this 11 means and what do you think this 6 means? Okay. So, well, we've got 6 protons and 6 electrons, so maybe that's what the 6 means. And then I can start changing it. Let's see if I change it to 7. Nope. So the protons changes this number right here, this atomic number. So when I change the protons, that changes the complete identity of the element by adding and taking away protons. When I change electrons, that seems to be changing it to be negative or positive. That makes it positive or negative. And the neutrons don't really seem to, here, they're changing it to be radioactive or stable. Okay? So here, an isotope is an alternative form of an element. So for example, here are 2 isotopes of boron. Boron should have 5 protons. So this is boron and this is boron, but the neutrons are different. And so when the neutrons are different, we call that an isotope. They're not changing the element, what the element is, but it's changing the mass. So the mass number is always going to be the protons plus the neutrons. Electrons are so teeny tiny, they don't even have a mass. And so when we talk about the mass of an atom, it's actually just the protons and neutrons that are added up together. Okay, so that's what an isotope is. So if let's say I want to know, let's go back to lithium. Okay, so here's lithium, and lithium has 3 protons. Okay, let's bring the electrons back down to 3. Okay. Now, if I have 4 neutrons, it's still lithium, and it's still stable. This isotope makes up 92% of the elements. So most lithium has 4 neutrons and 3 protons. How about if we have 3 neutrons? Okay, this is also a stable element. How about if we have 2 neutrons? Then it becomes radioactive and unstable. Okay, this would be unstable. Okay, and then this would be unstable. So it needs to have 4 neutrons or 3 neutrons in order for it to stay stable. Okay, so you're going to be just answering the rest of these questions. And then it's going to ask you about energy levels. So right here, you're going to show the energy level. Okay, and here are the electrons. And if you notice, there's 2 right here, and then there's one on this second energy level. And if we add another electron, then there's 2 right there. So you'll notice only 2 are going in that first one. Even though we add more electrons, they don't, no more will fit in the first orbit, but they come to the second orbit. Let's see how many the second orbit can fill. 5, 6, are there 9? There should only be 8, but maybe I don't see. Let's see. Let's go to a different one. Oh, here it is. Okay. All right. So, okay, here we go. Oh, I see. So there's 2 here, and then now we have 8 out here, and you can see this diagram shows the total number on the outer on the outer orbit. But if we add one more, it goes to the third orbit. So the first ring fills up with 2, the second ring fills up with 8, and then the second ring, we can see how many it fills up with. Okay, now it's full, and it's not letting us go beyond 8. So this one fills up at 8 as well. Okay, so that's going to be, we're kind of answering all the questions. All right, so I'm going to let you just keep working through that, and here talks a little bit about the periodic table. Hopefully this helped you kind of understand how these gizmos work, and then after you fill in your sheet, you can go ahead and turn it in. Okay, if you have any other questions, feel free to ask me, and otherwise I will see you next week.